Again, thank you guys for joining us today for the Oracle Primavera Special Interest Group online learning series. And at this time, I'll go ahead and pass it over to Charles.
Okay, great. Thanks, Christina. And this topic, 4D scheduling, the reality and the hype, is a session really that's probably been about 6 years in the works for me. And we'll get to that as we get into it. Let me just tell you a little bit about me. A lot of project controls experience, kind of grew into using Primavera in a lot of either smaller projects or projects managed out of Excel/Microsoft Project. So when I discovered Primavera, saw the breadth and the control capability, I was hooked. I had the fortune right out of school to work with some guys at last point there being passionate about communication who really emphasize that almost above everything else, that you've got to be able to listen if you're going to communicate well, understand, document, think through, and then come back with solutions and ability to implement. I wanted to start out by talking about what do I mean by hype. And in the first introduction I had to 4D, I went to San Francisco, Oakland Airport, just outside, and was invited to a presentation to Turner Construction about a new tool from Britain that had just been launched in the States called Synchro. And Synchro did 4D, and Turner had used it successfully to win some work at Sacramento Airport. So now we were at the Oakland Airport, and the team was considering using that, and specifically using it as part of a lean schedule review process. But the guy who had recommended we stop by and attend the session really said basically, hey, this is all hype. Everybody's talking about them, everybody's talking about 4D. There's not a lot there. It's overblown. It's too tough to do. We really make our bread and butter using Primavera platform and P6. So hopefully at the end of this session, you'll have a sense of whether or not 6 years later now in 2014, 4D scheduling, linking a schedule to 3D dimensional drawings is still in that category of hype. Hopefully keep you guys alert and keep me alert. We'll do this in a setting of talking about a tale of two projects, the big and the small. It was interesting coming out of that Oakland session, landed back in Las Vegas. I was partnered with a guy there in Las Vegas at the time, and we were essentially doing scheduling services, some project management, some consulting. We weren't really selling software, but we were invited, left Oakland, actually drove back to Sacramento, flew into Vegas on a Friday. Our first meeting Monday morning was at the Echelon project in Las Vegas. Now the Echelon was going to be 17 buildings, the most buildings that Tishman's Construction had ever managed on one site at one time. Just down the road, for those of you who go to Vegas a lot, is the MGM City Center. The MGM City Center is the largest privately funded project in the history of the world. It came in somewhere around $10 billion, give or take, after claims are settled. We'll see where it winds up. This project, the Echelon, majority owner Boyd Gaming, was set to be the second largest privately funded project in the history of the world. They had, from what we were told, over 90% of their funding in place, something north of $4 billion. This is looking out from the Encore, so if you've been to Vegas, it can help you, orient yourself where we are. We're looking at the Strip out from the Encore. At this time, steel was over 10 stories in the air. We went in and met with the lead scheduler, a lady by the name of Catherine, and Catherine said, we really are struggling here. We've never managed this much laydown area for this many buildings at a single time. So we're not sure how we're going to do it. And so, well, interestingly enough, we saw some software last week that might be just what you're looking for. It's a tool called Synchro. So we scheduled a webinar. The guy's connections for Britain. He ran it over, GoToMeeting. And then they flew in, did another kind of a morning mini session with a couple more of the schedulers. And one thing that in 2008, the Tishman had there on site were 3D designers. And they were eager to get the tool. what they had done to try to anticipate the problems is they had one scheduler who took site laydown drawings, marked them up using a Photoshop or similar package, put them into PDF, and essentially it created a PDF week by week for what the site was going to look like over the next 3 years. And of course, the only certain thing was that the site wouldn't look like that week by week. And the challenge of keeping up with what would the site look like, how would they get material to the site. And they said, we're great at building a single building at a time anywhere in the world. You know, we succeed over and over, but this many buildings, this much coordination. In particular, to the left, at the southeast corner, there's a tunnel that was going to come in and pop up about at the center of this picture that we're looking at here. And they're really concerned about access to that tunnel that was going to do their laydown space. Well, long story, very, very short now. We did about 2 days of training with Synchro. We were about a week into a 3-month plan to pilot Synchro and then sell it to the Echelon management team. Catherine took the laptop that had 2 days worth of preliminary, P6 connecting to Synchro data, showed it to her manager. So Wednesday afternoon. Thursday we had a purchase order. Friday morning at 10 a.m., Boyd Gaming put the Echelon project on hold. And it's still on hold. Steve Lynn has asked that they cover some of the steel with canvas and murals. As I've kept in touch with the team out there, there's still not plans to put the project back on the table as of yet. That left me with this kind of nagging question in the back of my mind. Would this 4D tool really have delivered for this project? Would it have solved the problems we were looking at for laydown, for access, for coordination, for safety, all the questions that had come up? That was 2008. Fast forward to a project where I am now. It's a public utility generation station in Huntersville, North Carolina, and a project to replace CM headers. Now, CM headers are water pipes that cool the generator. This same work was done in 2012, and it was my first time working in the generation site, first time in an outage, and I watched as this scope of work that the owner was responsible for, the vendor responsible for other replacement parts of the project, took 4.5 weeks. In spring of 2013, on this unit, with no other work going on, we looked at what we thought was an aggressive schedule. So maybe we can do this in 12 days, but the outage management said, no, we don't want to put it in this outage. We'll delay it until the fall of 2014 outage. And the question came up, could we do this in 72 hours? And what was driving that was access to space. You see there in that last point, the challenge was this. 11 crews needed access to 15 by 22 by 40 feet of space. And in that space, you also had equipment and scaffolding. And so in fairness, a lot of that 4.5-week duration was waiting for space and time to go to work. There are problems, of course, in execution. So we went at this pilot project with the 4D scheduling tool trying to answer that question. Can we do this in 72 hours? And here I want to stop and ask another question that's become really important to me. What does the schedule mean? My background initially was in construction projects for distribution, then in some mega project construction, and now a power generation facility. And at all the stops along the road, it's been very common to be in a room with people looking at a schedule and have the realization we have trouble understanding what the schedule means, or being in the field and have trouble understanding what does this schedule mean. And as a scheduler now, trying to build this, put it together, vet it, at the tail end, run earned value on it, knowing that earned value isn't worth anything, not a good schedule out of the gate. I've come to realize that it's very important that I communicate and understand what the guys in the field think the schedule should say, what the guys in the field think the schedule should mean. And then that becomes part of the challenge because those guys aren't necessarily going to be the strongest with the software or with some of our traditional schedule outputs. So I went into this pilot project that we kicked off conceptually, I think our first demo with the project team at Synchro was about a year out from the outage, so August 2013. We went into it having taken some key concepts from the time in Vegas, so not everything stays in Vegas. Had a little bit of knowledge, and it stayed in touch with the Synchro team. Kind of in the back of my mind, looking for a project where it makes sense to use the software. So the biggest one was model for the problem you're trying to solve. You don't go in and model everything, every nut and bolt. You're not making a movie. You've got a model for the problem you're trying to solve, which then of course means that you've defined what you're trying to solve. You build a schedule activity for every visible step in the model. And this creates a different approach to scheduling. You ask some questions that you otherwise wouldn't ask as you build the schedule. Your goal, of course, is always to increase schedule certainty and decrease risk. But you're increasing certainty in some different ways. The certainty that you can fit everything in the space at the same time. The certainty that everyone in the room agrees that this is the correct sequence of work. Decreasing the risk. You're identifying, because you're asking different questions, you're identifying problems that before you would not have discovered in the field. And that was perhaps one of the biggest light bulb type experiences right out of the gate. The guys around the table saying, hey, normally we would talk about this as we're in the field with the work order in hand, getting ready to do the work. Now here we are 12 months out, solving it, recognizing we have a problem, changing the work order sequence so we can execute the work in the field correctly. This fourth one was a big one. It didn't end up being as big an impediment as I thought it would be, but schedule design is another workflow. We know how to build schedules. We know the process. We know how to vet. We know how to do lean reviews. We know how to do vertical, horizontal reviews. We know how to do risk analysis on schedules. But 3D design or acquisition is not, and there we partnered, and that helped us. And then I'd seen this a little. This is why I was eager to find another reason to use a tool like Synchro for 4D and connect it to your P6 schedule. 4D provides exponential benefits. There's not a one-for-one. There's a multiplier effect. The time you invest, the resources you invest, the training you invest, and what you get out. So as building the 4D, here's a brief little timeline. We did about 6 weeks of our normal scheduled development, which is a kickoff meeting, and then we get back, a year out. We're meeting maybe once a week or every other week and refining. So we kind of did a, initial, here's what we've got to have, how many welders, how many riggers, how much, equipment. In that time, we identified an area of the schedule we really didn't have any knowledge because it was an owner group that travels to all the sites called Generator Services. We had to go do some research with them. But that's generally, give us 6 weeks to do schedule development. Did a point cloud field walk down, meet and greet with the vendor that we selected to partner with. Did a point cloud field scan, took 3 hours, 11 scans on a tripod with Faro scanner, full color point cloud was a product of that. Then our vendor did point cloud modeling. Took about 2 days to produce a point cloud that'll be the the basis for the model that I'll show you in a bit. And then I sent the P6 schedule and the Autodesk model from the point cloud to Synchro partner at 10 a.m. on a Wednesday morning. The following day, we had a kickoff for the pilot, about 20 of the key team members. And as I sent this, I've been marking up pictures, had about a 45-minute meeting with the Synchro subject matter expert who's going to do this initial one for us as part of the pilot. Anyway, 24 hours later, he was ready with the initial pass based on pictures marked up, reviewing the model file, marking up some screenshots as we're on the phone. And then we did about 4 days of round-trip refinements. Total on the phone with the Synchro software engineer, maybe had 5 hours total on the phone. At the end of this process, we were done. So once we had the 3D and the schedule, we were done in about a week. Now, once that was done, we came back and we would add additional model elements. We would continue to do schedule revision, and that was very easy. You'd modify the Synchro schedule. You can either use the API, or in our case, we're using an XCR file to bring a new updated schedule into the tool. And then we created some highlighting of certain areas in Synchro. So that was the process to build this, to get this out of the gate. Something that, as a 4D vendor, Synchro emphasizes is this, that they challenge the concept of a report. Schedule reports can be pretty dry stuff. Maybe it just looks like an Excel list of starts and finishes with a duration, resource, maybe some float. Perhaps it's a Gantt chart. Maybe you bit the bullet and are using Visualizer, so it's a more sophisticated Gantt chart, or it's time scale, where everything old is new again. The old P3 time scale is finally back, and you could use it now in P6. But we're all used to paper-based reports as the output of your effort in a schedule, as the tool you use to communicate. So this time we'll look at, and I tried to share just one screen, but like I said, PowerPoint's not my thing here, so give me just a second. And we're jumping over to the report output. Now, sometimes when I stop and start like this, the startup won't be smooth. It'll smooth, come back to the line. So here you're going to see this is a AVI file exported from Synchro. This is the top level. This is just a quick blob we threw in a sphere to represent the generator. Our real work is happening down here at the bottom level. We're going to do a little flyby. And then you essentially are seeing 3 pictures in picture plus your main screen. Again, all camera angles generated out of Synchro. So we had return header, 4 8-inch pipe cuts to make and get out, and a 14-inch pipe cut to make and get out. Same thing on the supply side. 4 8-inch pipe cuts to make and a 14-inch pipe cut to make. And then this is where we had to go do some research and kind of build the schedule for the first time. We also had to get the lead box out of the way, because the end game in here is get all this stuff cut, free, loose out of the way to be ready to lift the generator, but cut loose this top upper lead box area, travel the generator out, and travel a new generator in. The generator weighs about 1 million pounds. So part of our 4.5-week delay time during the 2012 outage was that obviously when the vendor who has a contracted duration to do this work needs the space, they get the space. So our object was initially right out of the gate in the outage, knowing the vendor had a little bit of work to do on a scaffold you're going to see here. Can we get this done? So now I'm going to play it. What you're going to see as it plays through, I'm using the cursor. This will be real time based on the schedule. This legend stuff will light up. Purple for where we're rigging, light blue for doing transit. And again, all this light up is controlled in Synchro. As we spin around, you see that's the Dance 4 scaffold. The scaffold design, the use of the rolling scaffolds is all vetted as we built this 4D. A couple other things to point out. We've got spring can hangers that hold the pipes up. The valves are in red. You'll see them go green as the water flows. For those of you who are into power generation, this is the main side of our lead box. To the right here is the neutral side of the lead box. One of the things we identified early on, I'm hitting pause here in a second on the video, is that we wanted to be done with the 14-inch cuts before the lead box team had to drop the neutral, because that was going to be a space conflict we just couldn't overcome, and one or the other side would have to stop. The other goal was to be done with the 14-inch work until we made a air arc weld at this level. It turned out with the scaffolding and the protection placed, that ended up not being a concern. This was another one of the targets. So anyway, soon here, so once it stops spinning, now the time's running, and you're going to see real outage time. You'll also see, and again, these are all things you can set in Synchro. Sometimes it'll go fast, sometimes it'll go slower. So we're purging the generator. Can't do any welding, but here we could mechanically put in place some supports. that we've drained down, and we're already breaking away, and we're removing. This is a crossover box air handling duct from the lead box. This pink signifies we're putting in a plate that needs to be there temporarily so they can run some fans at various times. We put a scaffold up here on top of the lead box so the vendor can begin getting in the upper lead box area while our guys are getting the lower lead box parts. Here on both the supply and the return header side, as we have cuts going on, you see that marked. And now we already see the supply header coming out. And these travel paths are created either in Synchro or in your CAD software, and you can place items on the travel path. Also, just as a visual indicator, as we were traveling out, this lighted up purple just to show that we had riggers in place to move the material. Now here in the lead box, we see them doing some internal work. They had to drop out some elbows. So you can see that essentially, if you can imagine it, you can create a way to communicate it. The other work going on, when we see yellow on these pipes, we partnered with Ariba to do precise metrology to know how to cut and insert and replace the pipes. So these came in ready to fit precisely. And here on the supply header, I'm going to pause it. So if you look here and here at the 14-inch and this outer 8-inch, that was our real target for success, not for full, did we do it in 72 hours, but for success was if we could get this in place with it welded and this in place and welded, and then we knew we were going to be okay throughout the rest of the outage. That was our core bit of work, to get this bigger section out and back in. And then it would be easier to find windows of time to come in and work. But the time to do the primary in and out sequence is where we really struggled during the prior outage. So again, based on the planned schedule, we're just at the start of day 2, and on both sides, we've hit our major target. And each individual pipe cut, these Ariba marks, were all carefully reviewed, timing, duration, number of people. But the guys would be in the field managing the work, providing their input, saying, no, there, I need more time, or I need less time. And so based on this, we came away with a pretty good sense that, yes, we could do this. It's not out of the question that 72 hours is a viable target. Now, as we came close to the outage, we had a couple of villains. Say that these are both good friends. Ron is a 30-year scheduler and former ops. For those of you who work in the utility, he's been in a power plant. We joke that ops is confused about the order of sequence, God or ops or God. It depends on the day of the week and the question often. But Ron took a look at the schedule that we built in P6 to support this Synchro model and said, we've never done anything this aggressive with our mechanical team in major projects. And as we got closer and he looked at it, he looked at the work orders, he said, this is looking more like 2 weeks worth of work. That was his take. Moody, who's the vendor subject matter expert for piping, he looked at the schedule and the time. He said, with my guys, everybody out of the way, let alone the fact that we've got 11 crews to manage in this space, he said, I see this as 6 or 7 days worth of work. And I'll even throw myself there on that board for just a little bit. I came to the 2 primary day shift, night shift guys who were going to be in the field running the work, and we targeted 72 hours, but as we refined the outage schedule and what had to happen, the reality was that they really had 6 days to get this work done, as long as they could manage that conflict between the neutral bus and the lead box and the 14-inch piping. And I told them, I said, you guys want to extend the schedule on it? And they said, no, we reviewed this with the teams. We're good with all our handoffs. We're staffed up on the equipment, the cutting tools. Ariba's, confident they'll give us the scan time we need. Let's keep it at 72 hours. So even in the back of my mind, there was a little bit, should we hedge our bets just a little bit? And part of what was there is this mechanical team, the guys that do the welding. They're kind of notorious, and I maybe could have put them up here as villains, but you'll see by the end of this it would have been an honest assessment. But they're notorious for not meeting a schedule, and perhaps even more notorious for not being able to give status on where they are in the schedule. So that was a cause for a lot of skepticism on a lot of individuals' parts going into this. Well, let's fast forward to day 2 of the outage. So day 1 of an outage, if you've ever been in an outage, everything goes crazy. Well, for us, we had a particular issue because we started out on critical path, not this work, but the work above. And the best way to describe it is the sky is falling. Right out of the gate, we lost 7 hours on critical path, turned around, lost another 6 to 7, so we're less than 36 hours into the outage, and we've already lost 13 hours. And I had planned for my day off to be that first day because there's not a lot to do. While what you're doing is you're waiting to get tag outs to be allowed to go to work, etc. So I came in planning to work evening of day 2. Walked at the building, and all I'd seen is email communications throughout the day. Has gone and done some research, and tried to help with some additional reports to figure out some recovery plans. I'm walking in thinking, boy, this is bad. This is really bad. Well, down below, no one had been down there that I talked to even see how the mechanical team was doing on this header work. So as I came in the building, on my way up to the project office on the what we call the 786, the turbine floor, I walked by the mechanical team. And what I saw there at the 36-hour point is that we'd already achieved our first kind of success goal. Both the return and the supply side were welded in place. And I spoke to our night shift lead, and he said, Charlie, we're going to be close to being done at 48 hours on the supply side. Well, that obviously, put me in a whole different mood going up to the project office. And the project office is pretty down. It's not good to lose that much time right out of the gate. I sat down and I made this comment you see here. I said, man, if everyone would just perform like the mechanical team, and then we were all laughing at kind of the absurdity of that statement, but here's a group that normally doesn't perform that well. They're knocking it out of the park and doing it with no oversight, no additional, they took ownership of this and they ran with it. And I put this picture up here. This is the supply side header. This is about what I saw when I walked in there at about hour 36. And what this gives you is a perspective. The Synchro model looks nice and neat and clean. But when you're down there, between power cables, welding cables, scaffolding, chain falls for rigging, rope, welding blankets, it's tight. There's not a lot of room to move around. But one of the comments that one of the leads made was this. He said, we've been here before. Because of the 40 schedule for the past year, we knew what this was going to look like before we even got here. Now this picture I took coming up on about hour 65. And this is the last piece of 8-inch pipe going in on the return side. And we knew the return side would finish a little later than the supply side because it was going to drain a little slower. And the only reason that both sides didn't finish in under 60 hours or more than a shift ahead of schedule is that the Ariba processing time took a little longer. You never know when you drain pipes how much they're going to spring. And the spring and the adjustment they had to make in their software, essentially on both sides, they had 12 more hours of processing time than we budgeted for in schedule. So even with that additional 12 hours of processing time when guys couldn't work in the field on placing this pipe, here's a picture 6 hours before schedule. All they've got to do is set this, tack it, and do the final root weld. So at the end of the day, on the supply side piping, they were done in 60 hours. On the return side piping, they were done in 72 hours. Safely, no incidents, no rework, no additional EC changes for engineering. All of that had been vetted out ahead of time. So we talked about whether or not there's hype associated with 4D. Now let's talk about the reality. What does reality mean? Well, that's pretty good there at point number one, the quality or state of being actual or true. Or the fourth one there, that which exists objectively or in fact. So what is reality? Well, having been through this project, seeing the success, to see what was 4.5 weeks of work done in 72 hours, it's a certain reality that 4D increases certainty. It increases certainty in your manpower, increases certainty in your materials, it increases certainty in your laydown, it increases certainty in your durations, it increases certainty in your sequencing. And there's a point here that's easy to miss, but it increases certainty when you have to make decisions in the field. Because the field engineers and the supervisors had been through this, when they had to make adjustments, and they did, as you always do on work that's as congested and as coordinated as this work, they had more confidence that they were making the right decision. Another reality, 4D decreases risk. As we worked through the Synchro models, and I showed them, this was kind of interesting. Our safety guys got more excited about the models than anybody else because they could now see where high-risk rigging evolutions were going to take place, where congestion should be monitored, managed, and for those of you who've been in an outage with a heavy safety emphasis, you know that one of your concerns can be, will we have safety stand downs? Will we have near misses, or will we have a risk situation that stops work? And so by engaging with our safety professionals, giving them the model, bringing them into the meetings, letting them take ownership, they were able to identify and communicate out. The other thing that happens is you get a lot of kind of traveling safety professionals who don't know your plant, don't know your project, don't know your people, and their initial instinct is to stop work. Well, we were able to sit down with these people and say, here's what we're going to do. Here are the risks we've identified. Here's what we're doing to mitigate them. And then do you guys see anything else? Is there anything else we should do? Do you want to challenge it? So that all of those safety-related risk questions have been asked and answered before we started, not while we were stopping work with 20 guys in the field waiting for a supervisor to conclude a discussion. All right, sorry, I just paused. I was getting a little blinking button from the Citrix or GoToWebinar. Looks like we're all right here. And this is a good place to pause, because this last point of reality is not something that would have been in this presentation until the workforce showed up a couple weeks before the outage. 4D creates belief. And if you're like me, a little bit of a math guy, a little bit of a technology geek, what's Charlie talking about? 4D creates belief. Here's what I mean. So we had 24 welders show up. And traditionally, welders show up and they kind of, are in that profile where they don't follow the schedule as it's given to them in a report. They're often not involved in the building the schedule process. During an outage, they're usually under the gun because things aren't going well and they're behind. So they came in and saw the durations on the schedule before they saw the 4D presentation, and I would hear rumblings. Oh man, there's no way. These times are too short. This isn't going to work. And then we had the support staff. So we had over 50 people in the room the first time we showed the crews that would be in the field. And also the support staff were FME, which is foreign material monitors, safety monitors, the riggers. Riggers had been involved and engaged a little more throughout the process. But here's a group, and you can kind of see. They don't like scheduled meetings. They're not engaged in scheduled meetings. Here's just another meeting that got through. And the worst thing was it was scheduled like 2 hours before quitting time on the last day of the week. So their minds are on, where am I headed after this meeting? And one of our planners, another fellow named Ron, not the scheduler, but another Ron, he says, hey, you guys need to watch this. So this is not like a normal outage schedule. So these guys have been working on this for over a year, and what they're about to show you, this is going to work. And then we showed the Synchro video that I just showed a little bit earlier. And you could see eyes light up, minds engaged, guys ask questions. A fellow by the name of Joe came up to me afterwards and asked me for a copy of the video. He said, that's the coolest thing I've ever seen. Because now I see what they're talking about. He goes, yeah, I think we can do this work. So the 4D created belief in the crews that were going to do the work. Now, I want to address some hype that may still be out there and how it relates to our experience so far and using 4D as part of our project scheduling and management strategy. First hype is that 4D takes a long time. I think we remember the slide where we talked about essentially in a week, we were done. If you have the right people, we all know that's a biggie. 4D doesn't have to take a long time. Another big emphasis there is figure out how you're going to do the 3D if at all possible. Get a good guy in-house. Hopefully, like us, you're starting to see a lot more vendors that produce 3D. Hopefully you're having better success than we are in getting our vendors to be willing to hand over that 3D. Which baffles me. We paid for it. You're creating it for us. It's ours. But still, it's a conversation you got to have. A lot of times, so far, we've not been successful in that conversation. The second point, 4D is expensive. And having watched this work, I would really argue strongly that the opposite is true. The most expensive decision you will make in a complicated, congested, or major project would be a decision to not invest in 4D. There's a project controls guy that we benchmarked with recently, and he uses the 110-1 rule. Something that he figures out is a problem in the field costs him $100. Something that he figures out is a problem in design costs him $10. Something he figures out is a problem in engineering or planning, it's only $1. And 4D really gave us the ability to make those $1 discoveries and avoid those $100 discoveries in the field. And then this last point, which I really do emphasize too, is pure hype. 4D replaces traditional scheduling. It does not. A good, correctly sequenced, correctly resourced, Primavera schedule ready to load into your 4D tool. You have to have it. Now 4D will then enhance that, but by no means does 4D replace your traditional scheduling process. Here are just a few things that we are looking forward to as future application. One is getting 4D started earlier, because we were a year out. The work order tasks had already been written. One of our goals now is as early as possible, get to 3D, get a basic schedule, start up 4D, and work it all the way through cradle to grave. And then if you see a whole list there of reviews, the reviews that we do that will be enhanced or made better, more efficient, especially this walk down. We have to go out in the field, it's loud, people wearing headphones, earplugs, and you have to communicate. If you can bring up a 4D model and say, here's what the work we're going to do, here's what we're going to go look at, here's the measurements we need to take, here's whatever we have to eyeball. It's a much, much better process. Training, we have some other projects where we're going to be doing the same project over and over in multiple outages. So you build the 4D model once, and now as you bring in new people, it's easier to onboard them and train them. Forensics, what went wrong. Fortunately, in this case, we didn't have to do that. We knew that we pretty much executed the way we were confident we could. And then what I haven't done, but that I hope to do, is some visual earned value. And simply what I mean by that is, we also, just like we send out schedule reports, we send out earned value reports. A lot of times it's glazed eyeballs or misunderstanding. Nobody can misunderstand a video. So side-by-side video, here's what we said we would do yesterday, here's what we did. Based on the scope of work and how we staff for this, we didn't have the ability to do that. But in the future, that's something we plan to do. So at this point, I will kick it back over to questions. For me, this journey into 4D kind of started in Las Vegas, Nevada. I'm hopeful that I won't get pulled into an outage assignment and then I could be out there in Las Vegas. maybe meet some of you guys. And again, I've got both Synchro up and the ability to look at some of this stuff. So any questions you have, feel free.
Great. Just a reminder for the folks that are on the line, any questions that you guys may have, please submit them through the question module, and then we'll take a few minutes to go through the presentation. Actually, at this time, we actually don't have any questions, Charles. I don't know if you have any other last-minute, any information that you want to let the folks know about, or actually, I just had a question come in, so let's answer the question first. How did you overcome the level of model detail discussion? I'm sorry.
Okay, I'm going to answer that the way I understood it, and then maybe give me some feedback if it's not the right understanding.
Okay.
You know, these pipe and other visual representations, we communicated to the team each time we got together, hey, we're doing this so we understand. So we're not up on the whiteboard trying to draw it. We're not looking at a 2D drawing trying to understand what the ramifications are. So we kind of set the expectation out of the gate that we're not modeling this to be 100% precise. And even the vendor we brought in to do this, we said, hey, we're not going to hold you to a cut line. You know, this is not precision for installation. This is modeling for visualization. And maybe that's the word I would, say that was big for me. We're just trying to visualize where we're going to be. This is not an attempt to, solve for or represent everything. Is that what the question was?
Yep, I believe so.
Did I read that right? Okay.
Yeah, they wrote back and said thank you, so I think you've answered the question.
All right.
Another question that I have is, do you see value in exporting model data back into P6 from Synchro?
That one depends. I did not do it. I know it's possible. With the right team, and I know of other construction delivery teams that are doing this, with the right team and the right process, yes, I do see that value. In particular, Synchro has the capability for new construction. Again, in this situation, we're taking something out, putting something similar back in. But the easiest way to describe this is, say you got 100 doors to install on 10 levels. Well, you sometimes you'll build that in Excel and import into P6, or you'll try to do a fill down in P6, but that's tough to do, to build up all those activities. Well, in Synchro, you can level by level select those doors going across. And if I have Synchro up now, if your 3D has been named correctly, and that's something I didn't talk about here because it wasn't really part of our effort for this scope, but if your 3D workflow is good, you can select all those, make a single click in Synchro, and it will create activities, and it'll even sequence them. So you say you're going to install the doors east to west, and then you can do it level by level, and you can very quickly build your schedule in Synchro based on 3D objects and bring that into P6. So it can actually be a time savings during schedule design. The type of refinements we were doing was generally a one-way. We'd review the model, make changes in P6, and send it, but that was more due to my comfort level at the time with Synchro, the scheduling tool, and the fact that we weren't using the API, but we were using the XER import-export. But I would certainly recommend that, again, with that it depends clause based on the project, your team, and what you're doing.
Great. Thank you very much, Charles. Just a reminder, if you have any questions, feel free to submit them through the question module. And then, Charles, I don't have anything else right now, but if there are any questions or anything that you want to leave with the audience today, if you want to give them a couple more tricks or tips or any kind of wrap-up.
Okay, I appreciate that. And I didn't stick my email address out there, I don't believe, but I know you can find it through OpSig, and like I said, hopefully be out there in Las Vegas. The biggest thing I would leave you with is kind of what I started with there earlier, is that communication point. I don't know how many of you are schedulers versus management types, and maybe that's something for the OpSig group. It'd be nice. One of the things I thought about coming into this, if we could have a way to maybe quickly do some polling. But for those of you who are primarily working with the data or the schedules like I am, don't lose sight of that importance of communicating and understanding the people you're working with. That's been one of the most rewarding parts of this process. And I'll leave you. You can tell I like working with these guys. we have a guy who does abatement, and actually this is really cool, so let me go, you'll see my messy file formatting here for a second. Abatement, there's nothing glamorous about abatement, right? You take paint off. You have to watch out for lead. But we had a guy, and I could tell he was upset in the meeting, so I stopped and said, DJ, what are you so upset about? He said, Charlie, he goes, they're ignoring me on this abatement. We had a lot of abatements to do overhead, and it stopped work, and basically everybody's forgotten about it. So I took the time to sit down with him and say, okay, DJ, show me the drawings, show me where you've got to get to. And what I'm about to show you on abatement, this is a laser abatement tool. Got a HEPA vacuum, whether it's lead or asbestos, it takes care of all those concerns. It's something that we brought in for DJs. It wasn't cheap, but with the cost of an outage hour, it was really cool. So anyway, so you see it's got his name on there, DJ. But essentially this laser comes along, blasts the paint off, and there is no heat applied at the surface. It just basically vaporizes everything in its path and generated tremendous savings in our outage work. And it's cool to touch. He's fine to touch that. There's no need for him to be in a mask. There's a need for special goggles. So that'd be what I would leave you with. Don't be in such a hurry to build out all the details to miss the opportunity, to talk to somebody, hear what their concerns are, and present it in a way that they understand it so that you've gotten the right answers and you've built a better schedule. And again, appreciate the time from OpSig and Christina for coordinating all these. And you guys have good weekends, and